This is Expanda and you're watching on YouTube. So in this today videos, right, we are going to solve Leetcode 3343 problem number, and the question headlines is saying count number of balanced permutations, right? Means this video is going to be, or this question is going to be tricky but beautiful blend of permutations, digit sums and dynamic programming. Okay, so let's dive in this problem. So what the problem statement is saying, just pause this video and go through. So let's continue to understand the Leetcode 3343 problem number. So the question statement is saying that we have given a string num and a string of digit is called balanced if the sum of digits at even indices is equal to the sum of digits at odd indices. Means the digit is called balance. A string of digit is called balanced if the sum of digits at even indices is equal to the sum of digits at odd indices. And then it is saying create the variable name, this one, to store the input midway in the function, return the number of distinct permutations of num that are balanced, and since the answer may be very large, return it to modulo 10 to the power 9 plus 7. And also saying that a permutation is a rearrangement of all the characters of a string, right? So what we have given that given string of digits called num, and permutation of string is called balanced if the sum of digits at even indices is equal to the sum of digits at odd indices, right? So what is your task? So our task is to count the number of distinct permutations of the num, right, that are balanced, and when we will return it, before that we have to take a modulo of 10 to the power 9 plus 7 and will return the answer, right? So it's really a very easy problem, but it's marked as a tough because there are some concept behind it that we will understand. Okay, so example 1 is saying we have given num is 1 2 3 and output is 2, right? Means example 1 is saying we have given num and answer is saying 2. How? So the explanation is saying that the distinct permutations of num are 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2 and 3 2 1, right? Means these are the distinct permutations, right? So among them 1 3 2 and 2 3 1 are balanced. Why? Because if you do what? If you do the sum of digits at even indices, right? And so even indices is what? 0 1 2, right? And then in this one it is 0 1 2, right? So same 3 digits are there because these are combination. So if you do the sum of digits at even indices is equal to the sum of digits at odd indices. So the even indices is 2, right? Let's suppose. So 1 plus, if you do 1 plus what 2, it become what? 3, right? And so 3 equal to 3, and here 2 plus 1 is 3. So like that we can say these are balanced one, and so number of count is 2 here. Okay, I hope you understanding, right? So what is the concept behind this problem? So there are a lot of concept behind this problem to understand, right? So in this video we will understand the combinations related to counting the permutations with the repeated digits, right? And the dynamic programming, we will use the DP state on digit sums and position counts. Also we'll understand the Pascal triangle. So I hope you understand the Pascal triangles, right? And the Pascal triangles will take C and K, right? And it will take the modulo. That I'll show you the example, you will remember. Then digits frequency array. So you can count digits from the input. You can take the modulo arithmetic and will ensure the result will not overflow, and will take the balance sum logic. So even and odd index sum equality, and the index analysis, how to calculate odd and even and position that exists, right? How many are there? and the efficient iteration will reduce the state space using the constants. Okay. So, if you are aware with some of the questions in your childhood, maybe in the preparation of IIT and NIT, right? So, there are the conditions used to give in the problem statement. Like, suppose how many ways can you choose 3 objects from the set of 5 objects, right? So, we used to do what? C and K, right? So, that is why we are saying that we use the Pascal triangle, C and K modulo will take, and then we'll return it, right? So, what we used to do, we used to use the Pascal triangle formula, that is C and K, and that is n factorial, k factorial, n minus k factorial, right? Then this is our set of given objects. So 5 are the given object and 3 out of which we have to choose, right? So we are doing factorial of 3 into 5 minus 3 factorial, and if you calculate is 5 into 4 into 3 factorial, 3 to 3 it will get cut, and then 20 by 2 is 10, right? So in the Pascal triangle we used to write like this. Similarly, we have to choose, because we have given a lot of indexes there, but we have to choose one, right? So that is why we have to use the Pascal triangle. I hope understands the videos, right? The way what I'm trying to say here. Just pause this video and go through this problem and example solutions. So what is the intuition we have, right? We want to count all the distinct permutations of a string. Let's suppose, for example, 1 2 3, where the sum of digits at even indices is equal to the sum at odd indices, right? In the zero based indexing, I am talking about the array, or you can say string. Okay, so for string of length 3, right? So if we'll talk about this, so 0 and 2 are the even indices and the odd indices is 1, right? So if you do the sum, so the permutations of ABC, the digits at index 0 and 2, let's suppose A and C are even positions and B is the only odd position, right? So what we will do, digit at the position 1 equal to digits of sum of digits at 0 and 2, means A plus C will become B, right? Exactly, this problem statement is saying that. So what we have given a num of digits, and we need to count the number of distinct permutations of num that are balanced, and where the balance means sum of digits at even indices are equal to sum of digits at the odd indices, right? See why I am repeating this multiple times, to understand the intuitions of the problem. Until you don't understand the problem statement, you will not understand the solutions, right? So I'm trying to tell you how we are understanding the problem statements and how we are going to solve it, and then after we'll take the modulo of 10 to the power 9 plus 7. Okay, so what are the to-dos we have to do to solve this problem, right? So as the question saying that, based on that we will create this variable and we'll store the parse value, right? Then we'll take the count frequency of each digit 0 to 9, right, in this, and we'll check if the total sum of digit is even, otherwise we'll return 0. Then we will do what? We will prepare a DP array, right? DP table you can say, and let's name of function at sum and odd count, and we'll store the ways to achieve a given sum using a given count of the digits in the odd positions. After that we'll do pre-compute of combinations that I have shown you, like that. We have to select the positions. Then we will iterate over 0 to 9 digits, and we will distribute digit count into odd and even positions, and after that we will update the state based on the valid combinations, and after that we will return function at target and max odd as the final result. Okay, so what we are doing, these are the things that we need to do, right? These are the condition 3, checkpoint at 3. We have to just mark total sum digits should be even, otherwise we will return 0. Okay, and then we'll prepare the DP, means the question belongs to the DP, dynamic programming, and we'll take the table function at sum and odd count, right? And when we will return, then we'll return target and max odd as the final result. Okay, so if you talk about the algorithm, right, this is that was a to do, right? And if you talk about the algorithm, so how we are going to do, so for I'm writing in a simple language to understand the algorithm. So we'll take n be the length of the input string num, and let's suppose if we take a count at D the count of digits D in num, right? And then we'll take total equal to sum of all digits in the num, and if the total is odd we'll return 0, right? Means first of all we'll define these things like n count at D, we'll find the total, and if total count is odd we'll return 0, right? Because impossible to split evenly, right? Because until there is even number, how we'll define all the even position, all the odd position, right? If there will be odd positions, the odd will be more, right? And even will be less, and so that the condition fails to find the permutations in this given string. Okay, so at this point we will return 0. Let target equal to what target equal to total by 2, right? And so we'll find the target, then we'll find the max odd. How we'll find the max odd, right? N plus 1 by 2. Okay, the what is the length? This is the length of the input string, right? N. If we'll do n plus 1 by 2, you will find the max odd. Okay, then we'll find the max even. N by 2 will be having the max even, right? Then we'll define if the function at sum and the total count will be there, right? Then we'll find the number of ways to choose odd count digits with the total sum, and then we will use the combinations to compute C and K. Means this is a Pascal theory, right? So if we have n is given and we have to choose K, means let's suppose if there is 5 group of people and out of that 2 people we have to choose, in that case we use the combinations, right? We will compute this and through the Pascal triangles, and we'll choose these things how to do that, right? That I have shown you the example. The number of ways to place j digits in odd position and the remaining in the even position, right? So what we will do here, we will define like this, and we will try to find we will define the f of sum and odd counts, the number of ways to choose odd count digits, and the total sum. So this is our purpose, and we'll compute C and K, right? Then we will go by digit in the dynamic programming. How we are going to do? So let's try placing j copies from digit I in the odd position, and we'll count at j in the even. So for each valid j, we will compute out ways. We'll do C count, odd count, and j, and we'll multiply even count and count minus j, right? And we will find the ways. Okay, and then we'll update the dp, right? How we'll do? So you understand these things, right? The C N K. So here odd count is n and j is the we have to choose k, right? And similarly even count. So then how we will find the k? So we'll found count at I minus j, and you will get what the choose, right? And like that we will find the number of ways, right? And then finally we'll return the dp state. Okay, so if you pass this function, right, if you do plus odd count and even count, if you will do here, right, if we will multiply this, we'll store each value, we'll update the dp state at odd count, and finally at max odd count we will return the final answer, because we have to return at the max count. Okay, so what is the breakdown of the algorithm, right? So first of all, in the first step, what we are trying to do here, we want to write the inputs and the pre-processing variables. Like we want to store the nums in the variable, this one, and we want to count the frequency at count and 10, and then we will compute total sum of the digits, right? Then we will do early check before continuing the program. Like if the total is odd, we'll return 0, will not continue the whole program, will return there because the input is wrong. Then we'll continue 3, the initialize the variable, will initialize the target as total by 2, max odd is n plus 1 by 2, max even is n by 2, and then we will initialize the combination of n plus 1 using the Pascal triangle, and then we'll initialize the dp table, like function at target plus 1 and max odd plus 1, because plus 1 we have to take. Okay, and then we'll set the base case like 0 0 is equal to 1. Then in the dp transitions, what we will do, for each digit I 0 to 9 we will move, right, because we have taken 10. So for each valued total digit counts, we will take so far. Let's suppose p sum, and we'll call so far. So for odd count in the range, we will count like even count will do p sum minus odd count, and for sum is equal to 0 to target, we'll try placing j copies from I in the odd position, and for that we'll do count at I minus j in the even position. You will find the even, right? Similarly, we'll check the bounds, like these are the boundary conditions we have to do, and will ensure I into j should be less than sum. After that, we'll compute weights. How we will find the weights? That I have told you, right? We will pass the combination of odd count and j, and combination of even count and even, right? And finally, we'll update the states of the dp, like how f sum at odd count, and then will plus equal to this one, right? Like we used to do, right? Into multiply the weights, and finally we'll return the result a target and max count. We'll take the modulo of here. So let's understand the code. It's time to understand the code, right? So first of all, we'll create the constant for the modulo operations. We'll take the modulo, we'll define the modulo in the solution class, and then this is our you can say main method where we have to write the code. So this is our given argument nums string, and first of all in the step what we will do, we'll store inputs in the variable name. This is called the variable name to store the inputs. So we'll create the variable equal to nums, and then int n equal to this into length. The variable will find the n. Now we'll take the count, right? Count frequency count of each digit 0 to 9, and the total sum is 0. Now in the step 2, we will count digit frequency and we'll calculate the total sum. And for that, for each character, we'll traverse, right? So to traverse each character, we'll take the int d, means digit. So character minus, if we'll do 0, we'll get the character, right? So we character digit will get, right? So character at d plus plus, if we'll do, we'll keep incrementing the frequency, right? Because we want the frequency of each digits, right? And so we are doing here plus plus. So the total, so the frequency of the digit will get updated in the count array. Okay. Now in the total sum, we'll do total sum plus equal to d, and we'll keep updating the total sum. In the next step, what we will do, we'll check the checkpoint, so that we will not further go, because if the total sum, if it is not equal to 0, if not divisible, means not even number of index, then we will return 0, because it is waste of time, because the odd will become more and even become less, right? So no need to do that. We will return 0 here directly. After that, if it is even, right, then we'll find the target equal to total sum by divide 2, we'll get the target index, and target, at the target we have to return the result, right? In the next to do, what we will do, we'll find the max odd. How we are going to find the max odd? So the position available for the odd indices, right? How we'll find n plus 1 by 2, right? Because n is the number of given indices, plus 1 if we'll do, we divide 2, so we'll find the max odd, right? Now we'll we will pre-compute the combinations of c number of positions we have given, and k using the Pascal's triangle. Then what we will do, we'll find the we'll create the combinations array, where we will pass the max odd plus 1 and max odd plus 1, right? So that we'll store all the combinations value here, right? We'll compute. How we are going to do, we'll create an for loop till the max odd number, and what we will do, combination I0 equal to combination of I equal to 1. So we will initialize like this first, and then we'll go for the all the combinations. So combination of ij, what we will do, will combination of I minus 1 and j, combination of I minus 1 and j minus 1, will take the mode, and we'll keep computing the all the combinations, right? We will keep computing, and we'll store here in the combinations array, right? Means the first loop will take from 0 to max odd, and between that we will initialize this value, and after that, because we are doing what, I minus 1 and j minus 1 we are also doing here, right? So for that we will initialize this value as a 1, right? Pre-compute means we have to initialize some value, okay, and then we will compute all the combinations, okay? So j equal to 1 to j should be less than I. Will keep going that, and we will find all the combinations. In the step 6, we'll initialize the dp table, right? So we have the function here, right? You can say the function array, so that will store target plus 1 and max odd plus 1 will do, and will keep updating the states of the dp in this function. So in the initial step, the state will of 0 0 will be 1 because this is the base case, and sum with 0 or digits it become a 1, right? So will prefix digit count will say 0, prefix digit sum will become 0, right? We'll take a loop through 0 to 9 digits, and we'll based on the we'll get the frequency, that is called digit count. You can say frequency count also of the digit, and we'll check if digit is equal to 0, we'll continue that. If not, we'll find the prefix digit count and the prefix digit sum. Okay, and we'll count like this. Okay. Now it's time to traverse possible counts of the digits used so far, right? So we'll take a for loop. We'll find the max. What is the max digit? Max count, odd count, and similarly the odd count, right? In this loop, we'll create another loop to traverse the current position, current possible count, sum, and for that we need the even count, and even count will find the prefix sum digit count minus the odd count. We will get the even count, right? And while traversing the current possible sum, what we will do, we'll find the current sum like this, like prefix digit sum, and target will pass. You will have the current sum. Similarly, you need the current sum should be either 0 or the which one is the max, right? If we'll do digit sum, prefix digit sum minus target, you will have the current sum. Otherwise we'll store the 0, otherwise, and then we'll do current sum minus minus. So this loop will continue, and we will traverse all the possible sum, and we'll finally will have the result where we will store at the current sum and odd count. So we are targeting the target and target sum, you can say target index, and then we want to count the max odd, right? But we'll count all the odd count, right? And for that we have to traverse, we have to place all the j of the d at all the positions, right? So for that, what we have to do, digit count minus even count we'll do, we'll find the odd count, right? And then we'll get the index value of j, right? And so for all the j, we'll traverse like this. So you have to find j like which is minimum, right? So these are called boundary conditions. You have to make it, and then finally you have to go for the remaining counts, right? Digits minus j, and you will find the remaining, go to even counts, and once you will have the k, you will find the ways, the combination of odd count at j and the combination of even count at k, and you will take the modulus. Finally, you will make them multiply ways with the previous state. How we are going to do? So the given res you have already calculated, but you have to reset the value again, right? So from the previous state, right, what we will do, the ways, and you will multiply this, you will find all the ways, and you will update it, and after that you will take the mod so that you will count it. Okay, and then you will store at res. Once this is computed, you will store at the dp state, and you will update the state of the dp. And finally, once dp state is done, you will return this one. I hope you understand, right? So what is the problem? Recap, right? We want to count all the distinct permutations of the string 1 to 3, where the sum of digits at even indices equal to the sum at the odd indices, right? For example, the string of length 3 is we convert indices, even indices 0 and 2, and odd indices become 1. So in the permutation ABC, we are getting what? A at 0 and 2 is C. So the position B is the odd position, right? So if you'll do here, so you will do A plus C is equal to B, right? So in the step 1, what we are trying to do here, we are trying to find all the permutations, right? And if you see, these are the permutations where 1 3 2 and 2 3 1 are the balanced ones, and that is why we are getting the balanced permutations are 1 3 2 and 2 3 1, and the answer count is 2. So after that, what we are trying to do, we are trying to understand the index assignment, how we are doing that. So max odd, how we are going to find n plus 1 by 2, we will get the 2. Since the odd indices are 1, you can say 1 based index position like 1. So the total sum become what? 1 plus 2 plus 3 is 6, and target is 3, right? Because target by 2 we are doing, right? and then we are getting 3. Target is 3. So we want one group that is the odd position to the sum to the 3. Then we need the high level algorithm flow, that we will take the DP and we'll do the frequency count, right? So we'll count the frequency count like this, and then we'll initialize the DP. So DP at f of sum, and odd count we'll do. We'll find the ways to fill the odd count, right? And we'll keep summing to the sum. After that, we'll fill the DP with frequency of each digit from 0 to 9, and we'll try to place J into the odd positions, like we'll do count at D minus J into the even. So how we are going to do? So we have to check the boundary conditions like this. Okay, means I into J should be less than target sum, and J should be less than odd count. And finally, we'll return f at target and f max odd count, right? This is look like a really hard question, but if you understand, then it is little easy. So permutations must be handled as a combination, not sure the brute force, since nums dot length can be up to 80, and use DP to count valid digit arrangements at the odd indices to reach the target sum, and you multiply by ways to assign the remaining digits, right? And so if you'll talk about the structure, like, then what are the combinations are there for 1 2 3? We have 1 2 3, 1 3 3, 1 3 2, 2 3 1. After that, if we'll do the rearrangement, right, we are getting 3 1 3, 2 3 1, 2 3 1, 3 2 1, right? So if you talk about this, so here we are getting what? Even sum 4 and odd sum 3. So we'll not do anything. If we do see here 3 1 3, so even count is how many? 3 odd is 3 for this one, right? And for 2 3 1, we are getting 2 3 1, right? So 2 3 1 and 3 2 1 both are balanced one, and so we will discard all others. And so that if you talk about the DP table, so there will be sum and the odd counts, right? And finally we'll return the value that we have here. Okay, so what is the complexity of this problem, right? So if you talk about the complexity, right, so time complexity is O of n square into sum, and space complexity be O of sum into n. Why? Because see, let's suppose we have taken the previous example, right, and the constant is saying that the time and space complexity we will become of n square into sum, because n we have given the length of sum, right, and which is less than equal to 80, right, in the constant if you see. So the sum will become what? Total sum of digits in the sum will become what? Let's suppose total digits are 9, so 9 into 80, right, it will become what? 9 into 80 is 720, right? And if you count the max odd, right, so max odd, how we are going to find? N by 2, right? So maximum digit of the places that we add at the odd indices, right? Let's suppose the maximum number of digits that can be placed at the odd indices, right, that will what? N by 2, right? That we will find the max odd. So the time complexity, how we are going to calculate? Because the core solution of this problem is a dynamic programming, right, because we are doing that DP approach that uses 2D table, right? So if you do function at or DP at current sum and the odd count, right, so the outer loop going from what? 0 to 9 means total 10 iterations are there, right? And for each digit D, we are doing what? We are looping over possible digits are you can say up to max odd should be less than equal to 40, right, let's suppose. And the loop over current sum is up to target, right, equal to total sum by 2, right? So it is let's suppose it will come around 360. Okay, so for each state count, like let's suppose the DP state, you can say the current and add odd count, we are doing what? How many j digits go to the odd positions? So j ranges from the max of we have taken max, and max is 0, and the count at D minus even count, if you remember, to the minimum of count D and odd count. So in that case, for the worst case, what will happen? we will count for each digit the max odd into target and the count at the that iteration. So though there are 10 digits, and so the for each iteration it will go for the all the given digits. Let's suppose less than equal to n digits in the element, right? So the total time complexity is roughly if we'll talk about, so 10 into the max odd count into the target into n, right? So if you see, observe, n is coming again, right? So n into target into n, right? Because 10 into the max odd into target into n, right? So n into target into n means n square, right? So we are doing n square into target, or you can say n square into sum, and that is why it is coming n square into sum, right? So the time complexities of O of n square, you can say. And if you talk about the space complexity, similarly we are taking what dp table we are taking, we are sum by 2 and max odd plus 1 we are doing. So we can say sum into n we are coming, right? And so because let's suppose we have in the sum 360, right? And n let's suppose is 40. So how many entries will be there? Approximately 14,400, right? And so the total combination will become what? Max odd plus 1. So max odd plus 1. So if into the max plus 1 combination is like combination of what n and k, right? So if you provide that, so 40 square over 40 square is it's also coming around 1600 entries, right? So the total digit of the frequency, if you'll find it, so it will have what 10 frequencies we have to add each time, right? Because 0 to 9, right? So the total complexity, if you'll talk about, so what will come? Sum into max odd, right, plus max odd square, right? But still we can call it what the sum into max odd, right? And so the sum into n we are saying the space complexity. Okay, I hope you understand the problem statement. If you go through the problem, right, the problem statement that we are doing here, right, you will understand, right, why the space complexity is coming o and n, right? Because we are traversing to all the digits, right? So the odd digits and j, right? So o into sum, right? O of sum into n, that is coming. Okay, hey guys, thank you for watching this video, and let's go to the Leetcode to understand the summary of the problem video. Okay, so as you can see, we have to take the constant of modulo operations, then we have to write it. What the first we need to store the variables, so we'll take the variables and we'll find this length, right? We are doing what, we are initializing the variables, then we'll count the frequency count. After that we will check the early check. If it is not sum or the total sum is not sum, right, if it is odd, will return 0. After that we'll find the target, right? Total sum by 2 will find the targets. After that we'll find the max odd is the total position plus 1 will divide by 2, we'll find the max odd. After that we will pre-compute we will do using the Pascal triangle algorithm, and you will find the combinations array will be pre-computed, okay, like this. Okay, and then we will initialize the dp, we are initializing the dp, right? And this will be the base case, and you have to find in the in this prefix digit count. Let me zoom out. Prefix digit count, and then the prefix digit sum, right? And after that we will make over the loop, so that we'll go through all the digits, right, 0 to 9, and then we will get the digit count, means the frequency of the digits. If it is equal to 0, we will not do anything, we'll continue for the next digit, and then we will find the prefix digit count and the prefix digit sum, like this. And after that we will traverse the possible count for of digits used so far, and then we will traverse the current possible sum. After that we will trying to place j copies of the digit d at odd positions, and then finally we'll go for the remaining will remaining go to the even one. how we are digit minus a will do, and we'll store. Then after that we'll find the ways, and once the ways we got, we'll multiply the ways with the previous state like this, and we'll find we will update the states, and finally we'll return the answer, right? So I hope you understand the video. Please let me know if you have any doubt in this video, guys, and if you submit this problem statement. Let me zoom. Okay, so you saw, right? It's submitted. Thank you for watching this video. If you have any doubt in this video, please ping me in the comment box, and please like, subscribe this channel so that you will get more videos and better videos, right? Because if you like this channel, YouTube algorithm will promote this video, and it will help me to write better videos for you. It will motivate me to create a better solution for you. And that's all for today, and thank you for supporting the expert funder.